Hello, welcome back students. Now we are in the second part of the video of polynomial and rational inequalities. We talked before about the polynomial inequalities and we found 5 steps to solve the polynomial inequalities. We're going to use the same 5 steps with a little change to solve the rational inequalities. So let's go and explain the 5 steps one more time. So we're going to use the polynomial. Remember that we set one side to 0 and then change the greater than or less than to equal, and then solve the equation and find the partition points and graph the number line and put this point in a number line and test the interval around these partition points. So the only difference between rational inequalities and the polynomial inequalities that in the polynomial inequalities we tested only the rational points. The partition points. In rational inequalities, we also add the domain points that they are not in the domain. We call them before the restricted points. So we're gonna talk about that. So again, we have the same steps, and then with partition points, step 2, and we have partition points for the solution and partition points for that are not in the domain. And then we create the sign chart, the number line. We test each interval, and finally we solve the equation. Let's get an example about that and we see how it works. So if I say x minus 3 over x plus 1 is less than or equal 0. So the first step, step 1, the right side is 0. It's okay. Step 2, I have to change the less than or equal to equal, so I have x minus 3 over x plus 1 equals 0. Alright, the third step is to solve this rational function, or rational equations for x. So all you need is just to set the numerator, so I have x minus 3 equals 0. Okay? So I have here x equals 3. And here is the solution, the only 3 that gives me 0. Alright, now, so this is the partition point. So another partition point of the domain, we set the denominator to 0 and find the restricted value as we learned before. So I'm gonna set x plus 1 equals 0, and then solve for x, and you'll get x is negative 1. So again, I'm gonna explain that one more time. So I find the solution of this rational function or rational expression, okay, and then in order to solve that, you may multiply both sides by x plus 1, but x plus 1 times 0 is 0. So this is the same, like x minus 3 equals 0. And then when we solve that, we get 3. Next, I need to get the partition point of the denominator, the restricted value. So I have one restricted value here, which is negative 1. Okay, so step 3, I create the sign chart. Okay, and how many points do I have here? I have 3 and negative 1. So negative 1, and I have 3. Okay, be careful here. 3 is 0. So I have 0 at 3. 3 minus 3 is 0. 0 divided by anything is 0. But negative 1 is not a 0. This is a whole, or is restricted value. So I'm going to call it here undefined. Undefined. UND. Okay? Or undefined. Alright, I'm going to test here. in each interval of these three intervals. So let's say x less than -1, x equal -2. So if I get x is -2, so I have here -2 minus 3 divided by -2 plus 1. So I have here negative and negative, -2 minus 3 is -5, so it's negative, and I'm not worried about the value, I'm worried about the sign. All I need is a sign. And -2 plus 1 is negative as well, so negative over negative is positive. So I have here positive. Okay? Now I need a point between -1 and 3. So -1 and 3, the easiest point is, yeah, I hear you said 0. Okay, so I have 0 minus 3 over 0 plus 1. So I have -3 over 1, which is negative, over positive, which is negative. So I have here negative. So what about this third interval? Let's take anything greater than 3. I'm going to take 4. X equal 4. So I have 4 minus 3 over 4 plus 1. So it's positive over positive. Therefore the answer is positive. So I have here positive. Now, let's look at the expression here. This inequality must be less than or equal 0. In other words, it must be negative. And I'm looking at the interval negative and include the 0. So where is the interval is negative? Here it is. So this is the desired interval. But be careful here. 1 is not included, -1 is not included, because -1 has a hole, the inequality has a hole. So I make it -1 and 3, there is a 0 at 3, and since it's less than or equal, I'm going to make this bracket. But this is a hole, and I'm going to make this. So my solution is -1 and 3. Is it clear? We're going to take another example to make sure that you understand the idea. Alright, so example 2 is similar to example 1. I want to get different ideas, so it will be easier for you to understand the concept here. So solve x squared minus 4 divided by x squared, which is less than 0. So what we are seeking here, we're seeking negative number, not equal. So you see the difference between these two. Okay, step 1. I have the right side 0. Done. Step 2. Change the less than to equal. So x squared minus 4 over x squared equals 0. Step 3. Find the partition points. So for the numerator, I have x squared minus 4 equals 0, because this is the solution. So that means that x squared equals 4, and don't forget that we have plus or minus here, so x is plus or minus 2. Okay? But this is the partition points. The partition points of the domain of the denominator, which is restricted value, I have x squared equals 0, so I have only one point is x equals 0. Okay, and here's how many points? 2, -2 and 2. So I'm gonna graph the chart, the sign chart, and how many points do I plug here? -2, 0, and 2. So I'm gonna plug -2, 0, and 2. Again, at 0, I don't have a solution. So I'm going to make it undefined here. Undefined. defined. Okay, now here I have 0 and I have 0. Let's remove this, I don't want to confuse you. So undefined add 0. Okay, I have 0 at -2 and 0 at 2. So how many intervals do I need to check? 1, 2, 3, 4. So let's plug any number, x equals something less than -2. Let's say -3. Okay, so I have -3 squared minus 4 divided by -3 squared. Notice what? This is squared, so they are always positive. So I'm worried about, I'm thinking about this number. But basically, the denominator is always positive because it's squared, so this is positive. Here's -3 squared is 9 minus 4. This is positive. I have positive over positive is positive. So here is positive. Okay, between -2 and 0, I'll get x is -1. And I have here -1 squared minus 4 over -1 squared. And again, this is positive, always positive. So I'm worried about the numerator. -1 squared is 1, 1 minus 4 is -3, so it's negative. So negative over positive is negative. So here I have negative. Let's plug x is 1, a number between 0 and 2. So x is 1. I have 1 squared minus 4 divided by 1 squared. So I got negative, because 1 minus 4 is negative, over positive, so I got negative. So here is negative. Okay, here's negative and negative. It's not necessary to have positive, negative. No, that's not necessary. So yes, you can have two interval, they have the same sign in a row. There's no problem with that. Okay, so 1 here is negative, and I got here the third one is negative. So what about the fourth one? Let's plug x is anything greater than 2, 3. And I have 3 squared minus 4 over 3 squared. 3 squared is 9 minus 4, that is positive, over positive, that must be positive. So here is positive. Now, let's go to the problem. I am looking for the negative or positive. Less than or 0, so negative. So now, here is my interval, my desired interval. But, watch, I have a hole at 0. So I start from -2, and this is less. So there is no equal. So I start with -2. And then I stop by 0 because I have a hole. Union, again, 0 and 2. And 2, even though that it's 2 is 0, I can't make it brackets because I don't have equal here. So I make it parentheses. So this is my solution. Okay. Alright, let's get different ideas, but with the same steps. So here, what if I don't have a solution? So let's see examples that I don't have a solution. So if I go with x squared plus 1 over x squared plus 7, which is greater than 0. First step, done. That at the right side is 0. The second step, we set it equal, so x squared plus 1 over x squared plus 7 equals 0. Partition point, the numerator, the solution, x squared plus 1 equals 0. So subtract 1 from both sides, I have x squared is -1. And definitely this is not a real solution, because you're going to get a complex number. So no solution. Okay, let's go for the domain. We'll see the restricted values. So x squared plus 7 equals 0. So x squared is negative 7. And again, this is negative, so I don't have a real solution, so no solution. Okay, that's weird, huh? So let's go with step number 4. I do the test chart. But how many points? I don't have any partition points. No solution, no solution. Okay, this is just a chart. And now I need to test. So guess what? Pick any points in real numbers and test. What's your favorite point? 0? Okay. So 0 plus 1 over 0 plus 7. I got 1/7. Okay, and I want it to be greater than 0. And it's greater than 0, so it's correct. So everything here is positive. And what's the solution? From negative infinity to infinity, or all real numbers, or from negative infinity to infinity. So here is a different idea than here. I have a solution in the numerator, the solution for the rational equation, and I have the restricted value, so I have values for both. And I plug the values on the number line. But here I don't have neither solution nor restricted values. So in this case I have to have all the real numbers. Okay, let's get a different idea again before we finish this section. So I'm going to get this idea. So I have 3x minus 2 over x minus 4 is greater than 3. Oh, here is, I have to perform step 1, because the right side is not 0. So I subtract 3 from both sides. I have 3x minus 2 over x minus 4 is minus 3. It's greater than 0. So I subtract 3 from both sides. Now the second step, so this is step 1. Step 2, I set the inequality to make it an equation. So 3x minus 2 over x minus 4 minus 3 is equal to 0. Now I have to use a common denominator here. And my common denominator is x minus 4, because this is all 1. So I have to multiply both numerator and denominator by x minus 4. So 3x minus 2 over x minus 4 minus 3 times x minus 4 divided by x minus 4. Alright, so now equals 0. So now I have a common denominator. I have here 3x minus 2, and negative 3 times x is negative 3x. Negative 3 times negative 4 is plus 12. This equals 0. Okay, and I'm cleaning stuff. I have 3x and negative 3x will be cancelled out, and negative 2 and 12 would be 10. And here is over x minus 4 equals 0. Okay, so this is step 2. Step 3, find the partition points. So we find the partition points. So the solution of that rational, I got numerator 10 equals 0. Definitely this is a false statement, so I have no solution. Let's get on the denominator. I have x minus 4 equals 0, and I got x is 4. So I have one restricted value and no solution. So I do the step 4, the line short line, and I have only one point here, which is 4, and it's undefined. So I have to test in two intervals, from negative infinity to 4 and from 4 to infinity. So let's plug a point here. Let's say 0 here. X is 0. So definitely that would be 10 over x minus 4. So I plug a 0 instead of x. So here is 10 over negative 4. So this is plus, over negative is negative. So here is negative. And with the other side here, I plug 5. So 10 over 5 minus 4. So positive over positive is positive. So I have here positive. And what I'm looking for the positive side here. So therefore, my solution is from 4 to infinity. So 4 and infinity. But here is for a whole, so would be open parentheses, open set of parentheses. And this is a solution of this one. I gave you 4 problems today about how to solve rational inequalities, and we learned before about polynomial inequalities. I hope that you get the idea and you'll be ready for the next section. Thank you, and see you in another video. Thank you.